Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is a ransom note. So let's go to LeetCode. Given to a string, ransom note and magazine, return true if ransom note can be constructed by using the letters of magazine, and false otherwise. And each letter in magazine can only be used once in ransom note. So crazy simple, and you're already familiar with this kidnapping thing engine using the magazine. If the kidnapper is illiterate, or maybe doesn't know how to write, he just or doesn't want to get caught, so that is why the kidnapper is using these words from the magazine to create the ransom note. I want that much money to release that particular person. So how are we going to do it? We are given a ransom note. This is what we have to create. This is what we have to use. So we have to use each characters only once from magazine to create the ransom note. So the brute force way of doing this would be basically going over each character in my ransom note and checking if it exists in my magazine, and that too, if I have used that character, then I will remove it from my list. If let's say if I've used this one, this A and this A, so these are two, this is used to create this A, so that is why I will get rid of this. Then I will check another A. So then if I can create the entire ransom note using all the characters in magazine, then I will return true, otherwise I will return false. So this brute force way of solving this problem will take big of, if this is the length of ransom note and this is the length of magazine, then this will take the time complexity of R into M, because for each character in my ransom note, I am checking for that character the entire magazine, and once I find that character, then I will basically return true. All right, for all the characters. So this will be of big of R into M time complexity. Now this doesn't have any space complexity, right? Or maybe it does. We will need a way of storing that what character has been checked, already used. But that was just to tell you like the brute force way of solving this. More optimal way of solving this problem would be, how about I create the frequency count of magazine. I create the frequency count of magazine. So I'll call it fric count of magazine, and I will just use the inbuilt function counter, and I will send in magazine. All right, so this will give me the dictionary. A appears twice and B appears once. Now what I do is I will go over all the character in my ransom note. So I'll just call it RN, ransom note. Okay, just remember this thing is just ransom note. All right, so I will go over all the characters, and if this character, if ch in my frequency count, so there are actually two things that can happen. First is this character might not exist in my frequency count, right? So there are two things that can happen. So let's check both things. So if ch note in frequency count, if let's say I needed some character to create the ransom note and that doesn't even exist in my frequency count in the magazine, then I will just I'll say return false, right? I'll just return false. That is one thing. Then another thing is, like, if this exists, then I will reduce the count for this because I'll be using that character. So in my frequency count, I will reduce this for that character. Okay, so -1. And if let's say this ch, if let's say in my frequency count, if this count becomes 0, that means I do not have any more characters left in my magazine, then I will delete this from my dictionary. So delete frequency count this ch. All right, I will delete it, right? So this will be the entire solution. And now I'm introducing some space complexity big of m. That's the space complexity I'm introducing, but I'm bringing down the time complexity to from big of m into r to basically just big of m plus r. That's because I'm using this counter to create this frequency count. So that takes big of m, and then another one takes this going over the ransom note characters. So that is r. So m and r are the length of the characters, length of the string of ransom note and magazine. So this is an easy peasy solution. We are doing it for the sake of doing it. This just gives us practice of writing our code. So brute force, you can write it yourself, but this I would say like immediately move on to this solution. This is much better. So to create the frequency count, you can either use counter. I will use counter, but you can use a simple dictionary and then fill that dictionary with the count of each characters. All right, so I'll just say counter magazine. All right, now for ch in my ransom note, all right, for ch in my ransom note, if this ch not in my frequency count, then I will return true. Oh, sorry, return false, because I cannot create this, right? Because this character that I need to create ransom note doesn't even exist in magazines anymore, or I have used it already. So otherwise, what I'll do is in my frequency count, now either it doesn't exist, you return false, get out of the matrix, or it exists, you just reduce its count. And if the count becomes 0, if this in my frequency the ch count is equals to 0, then delete from here this ch. And the reason we are deleting it, so that whenever you come across next time and you needed the same character but its frequency already became 0, here you can return false. Otherwise you just get out of the loop and you've gone through everything, and you could create the ransom note and you return true. So that is all of it. Let's run it on the test cases, and I will submit it. Okay. Definitely write the brute force solution as well, but time complexity for this one, time complexity is going to be big of n plus r. R is the ransom note's length, and n is the, or m is the magazine's length. So this line right here is this time complexity, and this right here is heading this time complexity. For space it will be big of m, because I'm storing all the characters count in a magazine. All right, so that is all. Let's go to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.